Welcome everyone. Today we are very excited to bring you the next episode of our 101 Ways podcast, and this time we are exploring all things data and AI. So, a bit about the podcast in general then. We wanted to give something back to our customers and the wider tech community. We've worked with some really exciting projects over the last 10 years and also have a very talented team of consultants with a lot of knowledge and experience, so we thought we'd share it with you. As our name suggests, there are 101 ways to solve a problem, and it's all about having the correct skills and expertise in place to find the right way forward that works for you. So we hope our podcast will go some way to helping you do just that. You can listen, download and follow us on Spotify, and also watch and subscribe on our YouTube channel. I'm your host, I'm Emma. I'm Chief of Staff here at 101 Ways, and I lead the practice and knowledge management function. In this podcast episode, I'm joined by John Parish. John, why don't you introduce yourself for us?
Hiya, I'm John Parish. I've worked with 101 Ways for nearly 5 years now. And prior to that, I've worked in just about every segment of the industry you can think of. Everything from warships to Xbox, with data mining and standard software as a service in the middle.
Awesome. Today we're going to be talking data and AI, which, I literally cannot scroll through LinkedIn for more than 10 seconds without seeing those buzzwords somewhere all over the place. So let's start by just getting some idea of what we mean by that. I mean, it's everywhere, but for today, what are we talking about? What is it? What isn't it?
So broadly, AI, artificial intelligence, is the general field that covers all aspects of machine intelligence. Obviously, in recent years, there's been a lot of developments with large language models and some very famous sort of what you might consider AI as a service, things like Google Gemini, ChatGPT, and they've had a massive leap in the past few years of their ability to understand natural human language and generate natural human language. So generally, although AI is a very broad subject that includes everything from data analysis through old school machine learning, most of the hype is actually around large language models. But the term itself is wider than that.
So what kind of practical applications then does it have for a company like us or for our clients or the people that are going to be listening for this?
So it broadly falls into a couple of different categories, I think. The stuff that all hype's about, the generative AI, which is from the large language models, it basically it's generative, so it can help if you're stuck writing a document or changing the tone of a document to make it more or less formal. LLMs are very, very good at that. They're also proving to have at least some use in code generation. Services like Copilot to actually help with code. And even ChatGPT, you can have that generate code as well if you want to. And all of these things are kind of anything where you are in any ways creative. It can help give you ideas, but they're nowhere near the point of replacing people yet. They're assistants, but not anything more.
That is the thing, though, isn't it? A lot of the stuff that I read online are that almost scaremongering of like it's going to replace people. It's like we won't need engineers in the future. Like, how far off that are we really? Do you think?
So I think we're probably quite a long way off that still. They're certainly a brand new category of tool that represents a major step forward, but they're just an evolution of the previous sort of machine learning. Although they look like in some ways they can look almost like they're sentient, almost passing the Turing test. When you dig into them, their limitations are quite obvious. And in particular, to take the code generation examples like Copilot, they can be brilliant, but they're only good within the scope of what they've been trained on. So if they've been trained on bad code, they will give bad examples. If they've been trained on one particular language or just a couple of frameworks, all of their answers will be shaped for that. And if you're using something slightly different, there's no reasoning ability in there. It's probably better to think about it like a much better Google search, Stack Overflow search, which is much easier to use. That's a massive benefit, but you can't rely on that to just do all of your engineering or all of your content generation.
I'm not sure that people really realise that, to be honest. The way that I see people talk about it and certainly, like you say, the hype around it. And I'm not sure that that's really coming across in what I read online so far.
Well, that's the problem with anything with hype. It focuses very much on the benefits, and there are certainly use cases where, for simple coding tasks, where it will do something really, really well and need next to no input. Particularly if it's a particularly simple example, and there's a lot of examples online. Say, I've never tried this, but I've no doubt if you ask Copilot to write a FizzBuzz implementation, it's one of the most famous things to write. I'm sure it would get that in one. It would be nearly perfect. But we don't, as engineers, doesn't tend to be what we end up writing. It's often new scenarios, new problems that we're trying to solve. And for that, it's close, but it won't always get there. What that means is that it's better for some things. So it's very, very helpful for writing a lot of boilerplate code, because again, that tends to be similar, almost templatey code. But if you rely on what that gives you, you often end up disappointed. And I've seen myself, both with people using Copilot and even in interviews that I've been running, sometimes people use Copilot there. What the suggestions that it gives can be brilliant, or they can be okay but not great, or in many cases they'll just give you slightly buggy code. Now the problem is, if you're sort of leaning back and letting the AI tool lead you with whatever the content is, or whether it's code or anything else, you may not catch those bugs. Worse, I've seen people think that they've been given a bug by something like Copilot or ChatGPT, but assume that they must be wrong because it's ChatGPT or Copilot. And so if you're not careful, you can end up sort of taking on bugs and pushing them through to your code repos. And so they can be a big benefit, but you need to use them with caution. You need to check them all the time.
It feels almost paradoxical. It's like, are we more inclined to trust a machine and a computer than we are human thought and critical thinking? Have we really reached that point, I guess, where we're just more intrinsically inclined to trust a machine?
Sometimes it seems to be that way, whether or not it's because of an explicit choice to trust the machine more, or whether it's just because, particularly with something like Copilot, it presents itself in the editor in a very similar way to previous technologies such as autocomplete, which are reliable. That clearly either works or doesn't work. And so it's very easy to just adopt the muscle memory of, oh, that's sprung in, I'll take that and carry on. So I think it's maybe some of one, some of the other. But certainly we need to keep in mind, this is the first generation of these sorts of tools. They're not reasoning. They've only got the data and the code they've been trained on. So again, I think the most helpful way to view it is like an automated Stack Overflow. There's some brilliant solutions on there. Almost everybody uses it. But would you trust every single thing on there to just push straight to production? No, you'd validate. You'd make sure you test it.
Right. So does then, you said before you've seen it used in interviews, and I guess and I've never had a problem with people using the tools that are available for interview. I'm not expecting people to know everything off the top of their heads. But then I guess what you're measuring for and what you're interviewing for is that critical thinking and knowing when to be critical, when to trust it, when to adapt it. So are you testing for and looking for different skills in engineers, do you think, as they start to use these tools?
Well, I'm a great fan of interviews should be as natural as possible. There's no point making it artificially constrained. So if there's a tool that will be available in day-to-day in the job, it's only reasonable that's available should the candidate want to use in the interview, because anything else is just an artificial, it weakens the value of the interview, I think. But I think in both cases, whatever tool you use, Editors, IntelliJ is a great example. It will do a lot of refactoring. So those tools are available, but just because any tool suggests something doesn't necessarily mean that it's correct. So what I'm always looking for in interviews and it's the same as in day-to-day work. It's not just can they take the output of a tool, it's can they exercise the judgment between writing their own thing or being able to discriminate what's a good suggestion and a bad suggestion.
And you talked before about the data that it's trained on and what it's being trained on. How do we know what it is being trained on then, the tools that you're using? Where is it coming from?
Well, so the problem is with the big sort of AI as a service thing is unless they publish every little detail, you can't fully know. But it's stuff that's going to be generally available. So open source repos, possibly the company's internal source code if they're happy to. Often, if you sign up to some of these services, you have to agree that your code is shared. So your own code could become part of the training data, depending on the terms of the contract that you've set. But that's only true for the big AI as a service models. It's still possible to train your own models or to get a pre-trained model run that locally. And then you have far more scope there. If you've trained your own model, which isn't actually as impossible as it sometimes seems to be when all the focus is on ChatGPT, then you can control exactly what data that's trained on.
But I guess the limitation is that it's a much smaller data set. So actually,
the benefit that the big players have is they've got the resources and reach to train it on billions of sets of data, which will be difficult for almost every other company to do.
Yeah, but as it gets bigger, then you're also bringing in more error and more.
Well, it's a double-edged sword. If you've got tens of billions of code samples, then that's a very complete training set. But equally, even for a big company, it's impossible really to vet that with any degree of certainty as to what's good, what's bad, what's malicious and definitely needs to be removed. So it's difficult to get that balance right.
When I think of, I'm thinking particularly of documents that I've seen generated by something like ChatGPT, and you can tell just by reading it, like, okay, this was not a human that wrote this, and it amazes me that people do that and think that we don't know that they're written by Chat. I mean, you can even go and ask it, right? Hey, did you write this? Oh, yes, you did. Oh, look at that.
Yeah.
Is the same true of code then? Is it? Could you look at someone's code and go, that wasn't human generated?
I think most of the time it's got a similar pattern to the text that you just described. You can recognise it because it's off somehow. You can't always define how, but it's not quite right. And the problem is with code, if it's not quite right, it might either have very little impact on the running code, or it might be a disaster. But in both cases, there's a good chance it's going to compile and it won't be obvious unless you're looking in detail. Now, I've no doubt these things will improve. These always do, as I say, it's the first version. It will get better, but until we've got proper artificial general intelligence, which I suspect is still quite a ways off, it's still going to be limited in the scope of what it can produce.
I don't want to feel like it's all negative, and I don't want to be the cynic, and everyone gets very excited when it's all, say, we talk about hype and the buzzwords and all the fancy schmancy stuff that goes around of it, and part of me is still thinking, what are you doing? You're training Skynet. Like, it's still there in the back of my head. I am that old school geek. But yeah, without trying to be too naysayer about it, the way that you're describing it feels like we're a long way off from it being certainly perfect. I'm sure it's very useful and applied in the right way. But it also feels like it's almost limiting or damaging or constraining the human creativity side of it as well. Are we asking it to do things that instead of doing the thinking for ourselves? Where is this actually going? I think of like I've heard a lot of people say that it's the kind of, like you'd said before, boilerplate code, that kind of low level stuff that you might get it to do for instead. But it's the kind of stuff that you might have got a junior to go and learn the ropes on and really get to grips with before they then go on and get more experience and rise to the seniority and mature in their thinking. If we're getting AI and tools to do that kind of thing, where does that leave the next generation of coders who are learning now and trusting this stuff, maybe? So yeah, where does that leave us for the future of engineers?
Well, it's an evolution of a tool. I mean, we've already got things like autocomplete. We've got code template generation tools in some cases to get some of the boilerplate done. We've got some frameworks reduce the need for boilerplate because that's all wrapped in. And so it's just an evolution of that. It can be a real benefit. Whether it limits you depends on how much you rely on it. If you're willing to if you're starting out in the industry, if you're willing to dig in behind the scenes, you'll do just fine. But if you do that, then yes, you're probably not going to learn some of those basics. And whatever your level of experience, again, if you just rely on the tool verbatim without thinking through or double checking what it's giving you, then it's no different than some of the refactorings an IDE might give you. It's going to be fine for 99% of the time, but you need to be sure you're not in that 1% of the time where it's not suitable. Or it might be suitable, but that different style doesn't fit your coding standards and you want it to look consistent with the rest of the code. There's it's not all it works or it doesn't. There's finer grained things as well. So, I mean, it can be a massive help, but use it as a tool that's an assistant, not replacing doing the actual work of thinking it through and doing the engineering.
Yeah, and I think I've always thought of like a good engineer is about curiosity and problem solving and creativity. It's not just writing the code. I think it's which bits are you asking the AI to replace for you? Solving your problem or just writing the code? Okay, let's go more then into, like you say, the data that's behind that then and how you train it, and being quite blunt, crap in, crap out, right? So so how do we know then? You already said like people can train their own. What do we really need to know about the data then that we're putting into these models?
Well, it's all about the data, really. You need to have confidence that you've got good quality data. The problem is that's a very broad subject because almost by definition it can cover almost everything. But you definitely need to understand. You need to be familiar enough with the data to understand what looks like good data, what looks like bad data. To take the coding example, if you're going to select code to train an AI on and you don't know what is good code, you don't know what's bad code, you don't know what's nonsense, then you won't be able to make a good suggestion. Andrew Carthy, one of the research scientists who was one of the co-founders of OpenAI, makes his point in one of his blog entries. You need to sort of immerse yourself in the data, figure out what the spread is, get an idea of how to visualize it if possible. That's not always possible depending on the type of data, but you need to understand the sort of data that you're working with. Otherwise, you've got no chance. And once you've got that, then you've got the standard. We've had data science as a discipline for quite a long time. You can understand. You can get an idea of what sort of data pipeline you need, what degree of normalization, if anything, you need, what deduplication you might need, because if data is duplicated, it might be unfairly weighted in your training set. I don't think there's no one size fits all guide for this, but you need to be aware of all of these things. You need to have that familiarity with it.
And I guess it still doesn't replace that kind of problem thinking. You've got to come back to what problem are you trying to solve, and therefore what data do you think you need to go and solve that? So what problems are people solving right now? I mean, that we go back to that kind of the hype and the talk around it. There are so many companies out there that are like, oh, we should be doing something in AI, and then they're left there thinking, okay, well, what could we do then? I guess there's a whole bunch of problems they don't even know they need to solve yet. But what are some of the good examples that are out there now that people are using?
Yeah, I mean, there's the thing is because data links to everything, you can basically improve almost any aspects. I mean, there's custom trained models that are producing new recipes. I heard of one case where a whiskey distillery made a new whiskey based on recommendations, again from a custom trained model. You've got new monitoring devices and services. I know one company that can do unobtrusive measurements of things like pulse rate just from a video feed, which obviously for some cases can be really helpful to a patient. But all of these things are actually eminently possible with the current machine learning technology that we've got and the current detectors and video cameras that we've got. But it's having that spark of inspiration to put the two together in that different way. And I think although there's a lot of hype in terms of large language models, I think in terms of practical applications, we're still only really at the tip of the iceberg yet. There's a lot more to come, but it's all going to be that combination of making sure the data is good, understanding what's possible, either with a commercial model or a self-trained model and putting the two together. There is one extra piece, of course, though, and that's validation. All the way through software, you need to have good testing to be able to know that what you're producing is good. It's that times 1,000 for anything to do with machine learning. The problem is that machine learning models, again, whether they're ChatGPT or your own custom one, they tend to fail silently. They won't give you an error message. They'll just miscategorize something or start producing garbage. So you've got to you've got to validate all the time. It's validate. That's how you get the benefit from this. And that's two different. There's two different aspects to that as well. So from your data, if you're training your own model, you need to split off your data and have a large portion of it for training, but you need to hive off at least a subsection of it to use for validation, so that you can validate it with data that you haven't trained it on. But even if you've validated your model and found that it's useful, you need to keep revalidating it. If you're a growing company and you're going from 10,000 customers to 100,000 to 1 million with new products, the way your customers interact with you, the patterns they're buying may change. So even if the model doesn't change, the data that you're providing it might kind of slip out of the sweet spot of that model. So that validation challenge is something you need to constantly be checking, because no machine learning model is perfect, and ultimately they're probabilistic. So you're not going to get a pass fail. You're going to get it's accurate enough for 80%, and then you get 10% false positive, 10% false negative. Is that a problem? Well, that depends on your use of it and your business and your use case. But even if that is good enough, only 70% accurate or 50% accurate might not be good enough. Well, you're only going to find if the data as things develop or drift together by that constant validation.
Actually, yeah, it's an interesting point, because you're effectively getting it to mark your own homework. How do you know if it's even true or not? Okay, so do you think we've solved that problem? Is that, like, you say, like, validated, but even like you're saying, like, halving off some of the data and sense checking against that, I still don't know if I would trust that, to be honest. I'm such a cynic. Who knew it? I don't trust anything.
I mean, if you're training your own model, having test data and training data, that split is fairly common, and most tutorials will build that in. But I think, but that's if you're doing specific machine learning. I think across engineering teams in general, that attitude of continual validation, and because that also applies to, is Copilot, is ChatGPT good enough? I don't think people are in the mindset of doing that yet. Because even if you're using, latest and greatest JavaScript framework X, Copilot today might be wonderful with that, and it proves that you get an 80% productivity bonus for your developers. But in 2 years' time, when you're on version 3 of that same framework, will it still be as good if the core model hasn't been updated? Probably not. And maybe you're working on an assumption you're getting an 80% productivity benefit, but you're only getting a 10% productivity benefit, and you're storing a lot of tech debt because it's putting a lot of out-of-date code into your repo. This I think is one area where most engineering teams, especially those that are using AI without being AI experts specifically, need to be a little bit careful. Right. You've got to be realistic about how accurate, whether it's your own model or AI as a service, or you're reusing an open source pre-trained model. You've got to keep an eye on how accurate this is and whether it's good enough for your needs.
Everything we've talked about so far feels like it's introducing an awful lot of risk. Not that that's inherently bad, but it's, going with your eyes open. But it is introducing risk into the organization, be it risk of incorrect data that you're producing, or basing it on models that aren't accurate, or how valid something is. But also, when I think of something like a ChatGPT or one of those larger ones as well, I've spoken to a couple of people that I don't think people realize that if you go and put your data into that, it's sending it off to different countries. There's different data protection rules. There's all sorts of things that I don't think people were really eyes open about the risks around this. The number of engineers that I deal with, in particular, I don't think risk is always top of people's heads when you're actually in my engineering pool, and understanding the business risk, the commercial risk that we're introducing by doing stuff like that, which feels to me like we're heading for potentially a gap in the organisation of execs and commercial people and risk-minded people who don't understand the technology well enough to understand the risk that's being introduced, and technical engineering people who don't understand the business risk that it might be introducing. So somewhere in the middle, we're going to have a big gap that it can fall through. Am I just being a real cynic and naysayer again, or do you think that's a real thing?
No, I mean, it ultimately, it's a new type of tool. It's a new generation of tools, and they can and are bringing a lot of benefit. But no tool's perfect. There's a downside with everything. The problem is we're in the middle of the hype wave at the moment, and almost by definition, that means everybody's focusing on the positives and overstating them, and nobody's really looking at the negative. I mean, it was similar when cloud computing became the thing. The ease of setting up complex infrastructure, it's so much easier, so much more reliable, it's so much easier to scale, but you're still storing all your data on somebody else's machine, potentially in another legal jurisdiction, which for some businesses is a major problem. And it's just about seeing through, there are benefits, but it's a case of ignoring the hype and evaluating it for what it is and making that judgment for your own business, for your own use case as to the benefit versus the risk. I suspect this technology, for almost everybody, the benefit far outweighs the risk, but that doesn't mean that the risks don't have to be mitigated.
Yep.
And a part of that comes back to the validation thing that I mentioned. But there's, as you say, there's other risks as well. And if you're using something like Copilot and you're in a very strictly closed source shop, you need to make absolutely sure that the contract that you've got and the tool settings that you've got are not leaking code out, because if for whatever reason that's too risky for you, you can't ignore that. There are ways to address it, but you have to address it.
Okay. Just going to go right back to the beginning, that kind of definition and something, and the kind of language that we've used already. So we've talked about AI, we've talked about machine learning, you've talked about general intelligence as well, and mentioned a little bit like the Turing test and stuff. Let's just start with like AI versus machine learning. Difference, same thing? What should people really know?
The problem is that a lot of these terms are used very differently by very different people. I tend to use the term as AI is the entire field and that covers everything about it. Machine learning is almost as big, because almost all AI these days is done on machine learning, which is where you have the machine train itself on data via a neural network, often using a neural network library like TensorFlow. So the difference is some of the older style things like the rule-based engines that we had in the 80s, I would include that in artificial intelligence because it was an early attempt at it, but I wouldn't necessarily include it in machine learning because it's not, the algorithm isn't self-training based on data.
Okay.
You have to explicitly code the rules for that. But again, these are down to, this is semantics, and a lot of people use things differently, and because of the hype, I'm seeing a lot more people use AI to mean the large language models that they can speak to in natural language and not include any machine learning or self-trained models. So you need to be aware when you're having a conversation with somebody what your definition you're working on and what definition they're working on. Otherwise, confusion results.
Okay, so put yourself in the shoes then of now an engineering leader who is getting tapped on the shoulder by their CEO. Hey, everyone's talking about AI. What are we doing? What should we be doing? How are we doing it? How did they start to formulate then a strategy, a plan? What do they do when they're getting pressure from the business stuff? We should be doing this stuff as well. Where do they even start? What should they be looking at?
Well, I guess the thing they need to do is decide what sort of avenues they want to pursue. Now, probably the easiest to get going is something like an AI assistant, either to write reports or to write code. And the benefit of that is it's very easy to start using it. You can sign up in many cases for free or just for a nominal fee per month and get access to the tool and start using it. And that's probably the best way to start for the large language model style side of AI. But you need to, again, validate it, be aware of the risks, understand what it is that you're signing up for. In other words, review it sensibly. Don't just follow into the hype, and be aware that even if it looks like it's giving great results, keep keep going with it. And part of testing is, if you need to, I mean, I don't know that I necessarily say this is vital for everybody, but have a test group, have a control group that's doing something different and compare and contrast, because otherwise you can't really evaluate how things are going. If you are not working fully open source and you've got things that you don't want to be sent out, then you need to read the terms and conditions carefully. You need to understand exactly what the tool settings are so that you can follow through with that. I think a bigger area is so that's one area. This is what I might call the generative AI. Another area, this is sort of painting broad areas now, is just every company will have data, whether it's just their own machine logs or customer data. You can derive a lot of value from that without doing any extra nefarious data collection. I mean, just understanding your own patterns of busyness on your servers can help scale more efficiently. And again, that's the sort of more numerical analysis that you'll probably get more value from with training your own models or using a custom trained model. The big famous large language models aren't as good at processing numerical data like that. But you might find there's a benefit from there because that machine learning is very good at finding patterns that are not easily visible to people. So you can get, a lot of benefit from that. And the third big area isn't just necessarily an engineering thing; it's the product innovations that might be possible.
Right.
I mean, you've already seen that some industries have got this quite well. A lot of professional cameras now will autofocus based on the segments of the image that the eye is looking at in the viewfinder. That's all machine learning, and that's such a good example of it because it's a very constrained space. It's quite easy to train the machine learning model on because it's not doing the whole photo pipeline. It's just doing one aspect of it, which is easier to work. But it's so natural. Any camera without that now feels like it's weird. But somebody had to have that first idea of thinking outside of the box because that wasn't a thing. Autofocus was done on almost on a few autofocus zones on the nearest thing to the lens.
Right.
And somebody has to have that idea. But for that, you need not just engineering, but product people, design people, also just being aware of what might be possible. So somebody can say, would this work? And then you can go and prototype it and see if it will.
So we don't just want the CEO knocking on the door of the CTO, they need the CPO and everybody else as well and go and figure out, again, back to what problem is it that a customer might need solving, and then technically is it possible, and then how do we do it?
I think that's the key thing with all of this. It's you're not going to just magically get profit by taking AI on. You've still got to do your engineering work. You've still got to split things down into small problems, and some of those problems might be well suited to particular machine learning applications or even to the large language models. You've still got to do your product work and your validation work. But if you do all of that, what you'll find is some of those segments suddenly allow this machine learning and artificial intelligence allows things that were infeasibly difficult or impossible before, which let you go on to things you wouldn't have thought of. But you've still got to do that work and put that work in.
Right. I guess that's the question it leads me to really is it's creating new stuff. Obviously, we think of that as you're going to solve problems for customers that should generate more revenue and more customers and be adding value into the product. If we're talking about efficiencies and productivity tools for engineers, then presumably that should lead to cost savings and to take greater efficiency within engineering. But actually, it's got to take investment as well. You say you've got to validate this stuff. You've got to get your data sorted. Is it an investment or is it enhancing your revenues and your general? Where do you think the balance is? Is it both? Where do we sit?
Yeah, it's difficult to know with that. I definitely think that this is going to be something that most companies will need to get some awareness of. That doesn't mean everyone has to become an expert. We don't all need to go and sign up for PhDs in machine learning. But it's like web technology. Not everybody is a front-end dev, but most big companies need to have some capability in that area. I think it's going to be similar with machine learning. But like with all the other, when it comes to the efficiency things, with things like the coding tools, we've already got a lot of that in things like IDEs that can auto-generate tests for you, or auto-refactor, or extract methods. All of these things can save a lot of time. And so providing the tools with some awareness of how to use them sensibly is probably going to be a good thing. But even in a world where you've still got all of these IDEs that can do all these efficiency-saving things, there's still some devs that prefer to use Vib. And that's fine. Let them. Things go wrong if you mandate it. It's just provide the tools where there's quantify that there's benefit, provide the tools where there is the benefit, and for your business it's worth the cost. Provide either the training, or if you're an engineer, take the responsibility on validating it. It is just a tool. It's not flawless. And then let people make their choice.
Okay, just before we wrap up then, is there anything else that you would want to share with people? Anywhere else you would recommend people do any more reading? I know you mentioned a couple of names and the kind of tools that they might be using. Where else can people go then? How would you wrap this up for people?
I'd certainly recommend Andre Karpath's blog. He's got some fantastic insights. I think it's worth. There's a lot of development in this area. So many of these things there are free tiers. So have a play with ChatGPT. Have a play with Google Gemini. Have a play with Bard or whatever the other ones are. Just get familiar with it. But also, if you are an engineer, be aware that it's not infeasibly difficult to train your own models. The libraries like TensorFlow are quite easy to use, and there's some fantastic tutorials there you can play with. And as a mid-ground, there's sites like Hugging Face, which provides many open source pre-trained models, and just play with it. Get familiar with it, because this sort of thing I think is going to be becoming more and more common. And so in the same way as if it was a new language or a new framework or whatever it is, we'd end up taking familiarity with it. I mean, if you look through coding tech, the past we've got functional programming, object orientation, domain-driven design. We don't these days do any one of those things, but we expect a good dev to have at least an understanding of all of those things and be able to use the skills where needed. And I think it's going to be the same way with this.
Here we go then. Right, thanks very much, John. We'll wrap it up there. We are going to continue this theme on data and AI for the whole of this quarter, so do please get in touch if there's anything else you think we should be discussing directly in that. Next time, I'm going to be joined by Anik Supan, who will be discussing with me how data and AI can support better agile ways of working. Don't forget, you can follow us on Spotify, subscribe to the YouTube channel, and we look forward to seeing you again soon. Thank you.